All right, in these next two videos, we're gonna design the 3D printed bolt and nut to really kind of look at helical sweep tool. So let's jump in. All right, we're gonna start with the hex shape and just do an extrude with the pallet tool. And I'm gonna grab a 6-sided hexagon and drop it there. So this is going to be a hex of 40, and I have a dimension here, which I don't want. And instead, I will grab the distance between those two lines and set that to 40. Good enough. The height of the hex head is going to be 13. And previously, I actually made this with the hex head pointing down, but really all the dimensions come from essentially the top plane here. So we'll go ahead and leave it the way it is. I'm going to add a circle, and this is going to be the inside diameter, or the minor diameter, 20. And this will actually go up the other direction. So okay, don't want to remove material. I want this to go up for a height of 78. Control D, there we go. And now let's talk about this helical sweep. So the helical sweep tool lives in the sweep dropdown, and I can actually create the profile and the cross section right here inside here. I don't have to have it created ahead of time. So if I click the front plane, the profile, we want to have an axis of revolution, so that's going to be the same as the bolt. And then the profile is going to go from down here, and it's going to go up a little bit beyond the end of our bolt. Now I have this going vertical because that's what I need in this case, but if I were to make my profile go like this, I would have teeth that would follow that, right? So just because this is going to be vertical in this case, and it frequently will be, doesn't mean it's limited to that as the only option. Okay, so I guess I'm sketching my major diameter, and all right, so this is 83 minus 13. Okay, so that is, it's important to know that I added this as the major diameter, so when I create the tooth profile, I have to locate it relative to the sweep path. Okay. All right, so now it's time to sketch the cross section. So we're starting down here. This is where we're starting. I'm going to start by putting my bottom. I'm going to start with the bottom of the tooth down here, and then connect to the major diameter, and close it up on the minor diameter. The distance here is the 1.2 millimeters. I'm going to add a, the angle in here is 50, right? It's 25 and 25, and it's symmetric, but another way to do that is just make these lines the same length, and that works out. So that's all the dimensions I have and the ones I need. I am starting, even though my profile starts here, I'm starting the tooth geometry below the start profile. So that means I'm going to start my tooth here, and then it'll start to go up. Okay, so right now the pitch is set to 7, which is why these look very offset. If I made it 10, you can see what's happening. I actually want it to be 5. Right, it says that the pitch is 5. Okay, and there it goes. It is a right-handed pitch. I Oh, it says clockwise. We have the option to have right-handed or left-handed. You do have the ability to vary the pitch. So you can have a pitch be one thing for a portion of the profile and then change. You can also have a trajectory. You can have the cross-section change along the trajectory using variables. So that sticks way too far up, and essentially what we do is kind of just come in and sort of chamfer the end, but we do that with a revolved cut. So we'll create a revolve on the front plane. Go ahead and drop the center line in there. And I'm going to use this clip model tool. Okay. Well, that didn't do what I wanted. Okay. The center diameter here is it's the 14. This angle is 45. And I think I can make this just stick to, you know what? I'm okay leaving the diameter, but if I really don't want it, I can just make it stick to the farthest outside. You'll see that it doesn't really matter. Okay. And I'm going to leave it as a solid and tell it to remove material. So odd looking cut, just being this line with a revolve, but it will work to get that geometry that we need at the top. And we're going to do a very, very similar step for the next one, where we're going to do the same thing down here. Okay, again, we're going to use axis of revolution, and we're going to add a, this diameter here is 40, and the angle is 30. Let's find that here to here. And again, as I revolve, make sure we remove material, and that'll kind of clip off those corners to give you that kind of traditional bolt shape. Okay. All right, so that is our helical sweep thread on our 3D printed bolt, and we'll take a quick check here. And we have 45.7. Okay. So now that you've seen it on the bolt, the nut will be very similar, but we'll have that in the next video.